We're talking to Mohammed from Würth Elektronik, who's going to tell us a bit about what they do. So Mohammed, do you want to take us away?
Absolutely, I'll introduce myself to begin with. My name is Mohammed Al-Alami. I'm the Field Applications Engineer for Wurth Elektronik. I've only recently joined the company. Wurth Elektronik is one of the many companies that belong to the Wurth Group, and our main product line is EMC and inductive solutions. Basically, we build inductors, we manufacture inductors, capacitors, ferrite beads, transformers, lamp transformers, as well as connectors that you will see in front of you here on the stand. My involvement really is to support the customers in providing solutions and giving them support in the designing stage of new products. Since my background is power supply design engineering, so this is right up my alley.
Excellent. And of course, yeah, where I first came across it was really in the inductors using switch mode power supplies, common mode filters, as you say, all your traditional strengths, that kind of area.
Absolutely. Yeah. I mean, the problem with power supplies has always been notorious for being the main noise producer in a board. So EMC solutions and of course the correct choice of power inductors is always key in order to improve the efficiency as well as reduce this noise signature of your DC to DC converter, or for that matter an AC to DC as well.
As a personal note, thanks, I've just had a design recently where I had in the switch mode inductor, I had the magnetic fields coupled into the ground plane and caused quite serious currents flowing.
Yes.
Putting in an ice shield inductor solved it, recommended by one of your engineers.
Absolutely, I mean this is what we have got here. We have got a little demo board that we had put together just to show the issues that you can get with noise. It's a little DC to DC converter where we are actually introducing noise into the board to show how we can clean up that noise.
So what setup have you got there? Could you talk us through it?
Yes, I'll talk about the DC to DC and then I'll go on to the other bits that we also work on.
Okay.
We have got this DC to DC board, which, as I said, it's a buck converter.
Yeah.
And it's got input and output filtering, and we are injecting noise into the output just to show you how we can clean up that noise. And on this side here, you can see using a spectrum analyzer connected to the input supply, we can see the noise in red here. The noise signature is fairly high without any filtering. The moment that we introduce a T filter, basically an inductor and a couple of caps down to ground, the noise signature drops way below the limit required. So that's where you see in green here.
So you've got the output from a listen, is that going into the spectrum analyzer?
Correct, yes. So the listen is just to isolate any noise coming in from the supply, and we hook up the listen into the spectrum analyzer. So that's one of the demo boards that we always use, just to visualize for people, because people tend to think about EMC as a dark art, you know, it's a black thing, it's a black art. So this way it makes it a lot easier for people to see the importance of sectioning a bit of the design real estate for EMC solutions.
And every peak on that spectrum analyzer plot, if that wasn't filtered out, that's going to be down your 3-meter long power cable, it's going to be radiating.
That is the problem. By the time you come to your EMC testing, which is usually fairly late in the design and production development stage, it's too late for you to start introducing components on the board, so you end up with a big, huge, bulky cable ferrite. So what we're introducing here is like very tiny little inductor and a capacitor into the board, which will help you know.
And you're saying earlier that these are actually your capacitors now, because I'm not...
Correct, yes, we do capacitors as well now. We have got aluminium electrolytics, aluminium polymers, we have got safety capacitors, as well as, of course, the MLCC, the multi-layer ceramic chip capacitors. We are going to be moving into, hopefully, super caps, but that's not at this stage of time. So.
Yeah, so even broadening your range. And of course you've been doing that, you also do the connectors, particularly the high power connectors, the ones you can actually bolt a lug down onto on the board.
Yes,
fantastic
these
devices.
Are fantastic connectors, they're absolutely amazing, and there's quite a bit of work that was done in order to specify these and make sure that they adhere to the requirements of the different manufacturers that we work on for these parts. So that's also something that I'm not very familiar with the connector side. That's the other part of the business. It's the ICAM part. I'm more the ISOS part. For me, connectors are just these little green plastic bits that are just putting on my board.
Power comes in, it doesn't really matter.
The outside. Well, that's all my interest. That's where my interest stops.
Yeah.
So, as well as that, we were talking earlier about this energy harvesting kit, which is also a nice collaboration that we did with LT and with Silicon Labs, just to show the potential as well for harvesting energy using a TEG, a thermoelectric generator, piezoelectrics, or a solar panel for that matter, to power up a little microprocessor. Interesting applications as well. Our parts in that, again, are the inductors and the capacitors, the EMC solutions, but it's different industries coming in together to put in their bits to show that it can be done, you can harvest energy.
And the support from you guys is really good, because I know I work a lot with linear tech parts, particularly the, say, the silent switcher range they got out at the moment.
Yeah.
And that's all Wurth parts recommended in there. But more than that, you've got the LT Spice models to support the information. You've got the Trilogy of Magnetics book.
Absolutely. I mean, one of the things that I think sets us apart as Würth Elektronik, which is really one of the reasons why I've joined the company, is it's based on the level of service that you provide to your customer, as well as, of course, the reliability and the quality of the product, which is manufactured in Germany partly. It's also being able to go in there, support your customer with samples, support them technically during the designing stage, so stay with them throughout their the design and development part, and give them all the support that they require from a technical point of view. So that's even more than you expect. That's our logo, so that's what we're trying to aspire for. So wireless power solutions is another thing as well that we also work on. This is a wireless power board, so there's no connection here, no electrical. This is plastic and this is plastic. So we have got wireless charging coils, transmitters and receivers. So we've gone into that side of the business. We've got magic modules, which are micro power modules or smaller power modules that allow you to use as current drivers or as a little DC to DC buck converters.
When you've got an old design with a 7805 and your site's running a bit hot,
that's it.
You can just drop in one of yours.
You know your linear regulator.
Absolutely,
yeah. Good man. So that's the good solution, where it stays nice and cool. You can put your finger on it, it's still all right.
Yes.
It's not going to burn you. Yeah.
It's always the good acid test for a design, really, yeah. So, how many burns do you come away with?
Absolutely.
Yeah.
But yeah, I mean, we've got the power inductors, which I did the presentation on earlier today, but we also have transformers, which is something that I'm really keen to talk about. I mean, the transformers that we have are adaptable as flyback, for buck, for push-pull topology. We have power over Ethernet transformers. So all the different types of applications that you can think about for a transformer we have available. And I know lots of manufacturers, lots of designers for transformers think they have to go down the custom line. And that's the power of the transformers that we have, is that you don't necessarily need to do that. We have got the WeFlex and the WeFlex Plus ranges, which, as well as allowing you 6 customizable windings that you can connect in whichever way you want to get to whatever turns ratio you aspire for, you also have ones with air gap, ones without air gap, again to allow you the flyback or the forward push-pull type topologies. And in addition to that, the different part numbers, which give you different inductances to allow you to adapt to your design requirements. So it's everything under one roof in a way.
And I know in our lab we've got one of your design selection kits with the flex inductors.
Yeah.
In fact, lifetime refills, as long as you put them into a design.
That's
great
absolutely
things.
true. It's it's the same with all of our design kits. We do provide this service. You get the design kit and it's a free refill for life. And we've got them for all sorts, for capacitors, inductors, EMC solutions, cable ferrites. They're available. And sometimes when you're sitting in a lab, and I know I've done it before, you know, something doesn't work or you want a different value, you really don't want to go back and make an order or go down to RS. You've got your kit in front of you. Oh, let's try this one. Oh, let's try this one. It might do the work for you.
I'm particularly with the filters. You sat there scratching here, going, right, put more filters on. It'll work eventually.
That's it. That's right. That's right. And that's what we do here. We've got different types of filter topologies, and we're demonstrating the effectiveness of the different types.
Yeah.
And
when you're looking at a textbook, it's always, I should clearly go for a T type. I should clearly go for a pi type. When you're sat there in real life, it's nice to be able to let's try a few. Let's see what happens.
You know, the issue as well with this is most of the time, it also depends on the layout, the tracking, the switching frequency. There are so many parasitics that do not appear when you're doing sometimes the simulation or sometimes the mathematical modeling by hand. They only appear when you build the board.
Yes.
And that's where you actually need to use a hand solution. You know, you go in there and put in your components in and see whether it works or not. Not, of course, that you're going to be having finger in the air. You're going to do some mathematical modeling before to show you where your issue is and where you can, what best way to resolve it. But at the end of the day, having the kit available for you makes it a lot easier. And we're also available to provide samples if you want specific values that are not available in the kit. 24, 48 hours, the samples are free and they're with you.
Excellent.
So
yeah,
that's another thing. We've also got the trilogy of magnetics, which is an amazing book. It's got pretty much everything that you need to think about when it comes to magnetics theory, losses, different topologies, even some reference designs as well.
Yeah.
And we've also produced the LT Spice simulator book. I know I've struggled with LT Spice. I haven't come from a simulation using LT Spice background. I use Sabre, I use Simulink, Symmetrics, but I've never used LT Spice. So that book has been quite useful to get me going, because there's not much information available.
And a lot of information you don't find elsewhere. I had an issue where I ran out of RAM on simulation. It sort of cannot allocate contiguous memory block.
True.
The answer was in the book, straight in the book.
Correct.
How to type a command into Windows, expand the virtual memory.
And that's it. Hey presto, you're going again.
Absolutely.
Instead of scratching your head. Oh, how do I do that?
Quite.
So we're continuing on with this trilogy, with these publications with the ABC of capacitors, which has come online recently as well. Again, a very nice little small guide on capacitors, just to give you a bit background on what capacitors are and what losses associated with capacitors, what to look for in terms of design parameters, and the types of capacitors to use. So that's the sort of a general view of the product line that we have.
Absolutely. Well, thanks so much for your time, and
it's a
pleasure.
Thank you very much for allowing me to
you.
have a chat with you.